Hey, Year 11s, thanks for coming along, guys. Okay, so today I'm going to be going through the edexcel iGCSE Chemistry, paper 1 from June 2014. This has been asked by one of my subscribers since they, just to see if I can give a shout out to that person. Got to use my phone to do that, and my fingerprint scanner doesn't work. It's garbage. Just to pop up and say, this is to Tassim. So he's asked me to do, he said the May 2014, it's 1C from edexcel iGCSE, said that the paper was a complete disaster for me. Can you please solve it? So I'm happy to go through it, and I think there's some value in this with you guys coming up to your mocks. So let's crack on, guys. I'm going to do this in 2 parts. I will complete it today because I'm going to do part 1 now, try and get halfway through the paper as best I can. And then the second half is going to be lesson 2. And then you guys can switch with my other Year 11s to watch the other half of the video. So you guys are going to get part 1. They're going to get part 2. So let's crack on, folks. Share screen. Share screen. I'm going to switch my cam so I can do all my dancing. Woo! There we go. We're up and running. I like it. Right. Share screen. We're in. I'm going to open up the YouTube video so I can see your chats because that's important. You guys will be able to. We're in. I'm going to open up the YouTube video so I can. There you go. Got it. And then I'll pop out the chat window because I know at least the sound seems to be reasonable quality. Cool. So I'll get rid of that now. It's all up and running. All right, Isabel. Hey, everyone. I see everyone there. Right. Let's crack on, folks. Okay, so this is, I've got my little fan there, just trying to keep my laptop cool. Okay, so May, yeah, there we go. It's nice to see that this coincides with what you wanted me to do. May 2014, paper 1, 2-hour paper. Let's crack on straight away. So, okay, so first thing that came up is naming equipment, very reasonable. We've been picking up, my computer is so laggy. Oh, is it me? Is it me or is it you, Shan? Oh, I'm worried about that now. Can I just have a quick shout out on the chat if everyone's okay with hearing me and the quality of the video is okay? I did have issues with my internet about a week back now, and I had to cancel all my lessons based on that. So just give me a quick shout to make sure it's okay. Okay, no, it is me. No, sir, you're not laggy. Excellent. Cool. Okay, so measuring cylinder, it makes sense that they've ticked off that one because it's a very common one from Year 7. So B, filter funnel, seems reasonable. Filter funnel. Filter funnel. There we go. Then C, conical flask. That's nice. Now, that's interesting because there are 2 answers to D, aren't there, depending on the size of the tube. I'm going to assume... what are we doing in this particular piece of, it doesn't say. So what they're going to do is they're going to allow both. I'm going to put a test tube. Test tube is the most commonly used piece of equipment. It could be a boiling tube. Could be. I think it's Shanley. Okay. E, a graduated pipette. I'm actually suddenly going to realize that I'm going to switch to black and also reduce my pen size. Yeah. So B was a filter funnel. Filter funnel. D is going to be test tube or boiling tube, either one. Tubal? Why have I put tubal? Don't know. Next one is, this is the first piece of any difficulty, a graduated pipette. There we go. And E being a beaker. Nice and easy. Cool. The only one of any difficulty. Give the letters of the 2 pieces of apparatus that could be used to measure accurate volumes of liquids. Well, a graduated pipette is one of them. I actually think graduated pipette, they'll probably just accept in the mark scheme pipette, just so you know. Aren't boiling tubes larger? That's correct. And I don't know whether or not that's a large or a small one. You don't know. There's no comparison for it. And the other one is a measuring cylinder. Can I just point out at this point, measuring cylinder. Can I also flag up that the graduated pipette is about 10 times better than if someone said which piece of equipment would you use for measuring volumes accurately, you would only pick that one. That one it doesn't do variable volumes. This is a fixed volume, but it does it much more accurately than a measuring cylinder. Much better. Mr. Duncan, it says write the letters. Oh no! You're absolutely right. I would have definitely lost that mark. I'm still going to write in the words as well. Graduated pipette. You're absolutely right. Yeah, give the letters of the two. So that would be graduated pipette is E and measuring cylinder A. Yeah, thanks for that. Crude oil is a mixture of substances. Which word best describes the main substance in crude oil? Hydrocarbons. You know this. Try and make my pen a bit thicker now. There we go. Hydrocarbons. Bases, opposite of acids. No. Carbohydrates. No, that's biology. Elements. No, definitely no elements in crude oil. Crude oil are hydrocarbons, compounds made from carbon and hydrogen only. So they're doing in-lab fractional distillation. It's not actually fractional, it's just distillation. This is simple distillation, guys. This method here is simple distillation. They don't even have a condenser. Distillation. So we need to put it in order. So it gives us U is the second one. Fit the thermometer to the boiling tube. So connect a delivery tube to the boiling, pour crude oil into the boiling tube. Collect each fraction in the test tube, heat the crude oil. So T is going to be last. Yeah, collect it. Fit a thermometer, heat the crude oil strongly and then, gently at first and then strong. So that's going to be V. There you go. I'm going to cross them out. V's done. T's done. U's there, so U's done. Right. Pour crude oil into the boiling tube. Connect the delivery tube to the boiling tube. I don't think it really matters which way round you're going to do that. Don't see why it would matter. I'd probably say pour the oil in first, because pouring the oil in once it's all been connected is going to be a bit of a nightmare. So I'm going to go for that one. That'll be interesting to mark. Yeah, just checking. So connecting. So S, pour the crude oil into the boiling tube, number 1. U, fit the thermometer to the boiling tube. R, connect up the delivery tube. Yeah, reasonable. Now we're going to heat it gently at first and then collect each into boiling tubes. Fine. Yeah, that'll be interesting. Serve it. Next, how many protons does this nucleus of the atom contain? Right, that's quite clever, that, because we know that if it's an atom, in an atom, the number of protons will match the number of electrons. So we've got 2 in the first shell, 8 in the second shell, and 2 in the outer. So it's going to be 12. 12 protons. Yeah, the reason being is the total number of electrons is 12. Yeah, 12e minus. Therefore, in an atom, there must be 12 positive protons to cancel it out. Seems reasonable. Give the group on the periodic table for X. So we know that the group number is the number of electrons in the outer shell. So it's going to be, and give a reason. Group 2, 1 mark, followed by the atom. The atom has 2 electrons, and you need to write the word electrons. 2 electrons in outer energy level. We're done. Outer energy level. Finished. Give the formula of the ion form for element X. So it's going to be X plus 2. Yeah, we know that whenever we have an atom becoming an ion, it's going to lose the number of electrons in its outer shell if it's below 4. And then if it's above 4, so 5, it will gain the number to reach 8. Except for hydrogen, of course, which is the tricky one. But otherwise, we're just trying to get to 8. So in this case, we know it has 2 electrons in its outer shell. This is when my laptop just goes a little bit slow. It's going to lose him and him to become an ion of plus 2 after losing them. Yeah. Next, calculate. I'm just going to check that my laptop is on full power. Yeah. So calculate the relative atomic mass of X. Give your answer to 1 decimal place. I like it. So this is a good old RAM calculation. We have 3 isotopes, each with their percentages. So we're going to do 24 multiplied by 79.0 brackets. Add that to 25 multiplied by 10.0, close brackets. Add that to 26 multiplied by 11.0, all over 100. So I'm going to run that through my calculator exactly as it says there. 24 times 79, close brackets, plus brackets. 25 times 10, close brackets, plus open brackets. 26 times 11, close brackets, all over 100. Now, before I click answer, it's just nice to realize that it's going to be really close to 24 because there was more 24 than anything else. And the answer is 24.32. So there's the answer. Yeah, but then it says, give your answer to 1 decimal place. So the final answer is 24.3. But chances are there's a mark for that guy, a mark for that and that, a mark for the calculation bit, and a mark for the final answer to 1 decimal place. I like it. Seems very reasonable. And it's closest to 24, which that's telling me I'm in a good ballpark figure. Just to quickly mention these questions, you don't always have to get percentages. Sometimes they will just give you ratios, and the ratio might be something like if they switch that there for ratio, it would just say a ratio of 8 to 1 to 1. Yeah, and what you do is you do 24 multiplied by 8, 25 multiplied by 1, 26 multiplied by 1, and instead of dividing it by 100, you divide it by the total of the ratios. Just mentioning it. Next. Okay, the diagram shows how hydrated copper sulfate can be made by reacting copper 2 with... So this is a super common question. edexcel love the making of a hydrated copper 2 sulfate. This is one of those practicals you do in school, and it's really important because it comes up a lot. And they give you these steps. So... Stage 1, dilute sulfuric acid, add the copper 2 oxide until an excess and stir, filter the mixture, heat the solution until hot and saturated, allow to cool for crystals and then filter. Why is the sulfuric acid heated in stage number 1? Right, because this reaction between copper 2 oxide and sulfuric acid has a high activation energy. So the sulfuric acid needs to be hot. It's to provide the activation energy. Yeah. So provide activation energy for reaction between sulfuric acid and CuO, copper 2 oxide. Seems reasonable. How would you know when the copper 2 oxide is in excess? Because what will happen is you will have leftover black solid when the reaction is complete. Yeah, you keep adding until the black solid doesn't disappear. Yeah, when the black solid, which is copper oxide, and the black solid brackets CuO, copper 2 oxide, when the black solid stops dissolving, brackets, black sediment left in beaker. Yeah, in the acid. Why is the mixture filtered in stage 3? To remove any of that excess copper oxide. To remove the excess copper oxide. So what this looks like, I know they've got their images. Yeah, you've got your colorless sulfuric acid. You now add a black powder. Yeah, this is really black, by the way, as well. A black powder which goes in, and that black powder will then just sit at the bottom. Yeah, and the reaction will then take place, and this is the reaction, CuO plus sulfuric acid, and I'm going to form copper 2 sulfate and water. And this is blue. Yeah, so the beaker's going to turn blue. It's going to be like a pale blue. There we go. It'll suddenly turn blue as I form copper sulfate. And then what's going to happen is I'm going to have black solid left behind at the bottom because I had it in excess. So what I need to do is I need to filter that out. Yeah? Next, why do crystals form when the hot saturated solution cools? When temperature decreases, when temp decreases, solubility decreases. So a precipitate, so I'll say crystals. So crystals form. So crystals form. But in reality, we know what the mark is. That's a really easy one. As temperature decreases, solubility decreases. State the color of the crystals formed in stage 5, blue. Nice and easy. The crystals are removed by filtration and then dried. So just a suitable paper towel. Done. Paper towel. Yeah, it's always a good shout. Try to, in this case, because we're forming hydrated, this, I think, look, yeah, we're forming hydrated. If you put it in a drying oven, you're going to lose that mark. Because if you put it in a drying oven, you'll continue to evaporate the water. You just want to dry it with paper towel in this particular situation. So, done with question number 4. Wow, 4, smashing through it. Let's keep going. Okay, use the information in the table to identify the substance. Which one is a metal? The one that conducts all the time. One that conducts when a solid, it's going to be B. Seems reasonable. Yeah, it's got a high melting point, a high boiling point. It's conducting when it's solid. There's only one other thing that conducts when solid, and that's graphite. But then graphite can't be made molten, so it can't be graphite. So there's your metal. Which one could be diamond? Oh, that's easy. That guy. It's the one with the highest melting point by a mile. So that's going to be D. Yeah. Is a gas at 20 degrees. Boiling. There we go. Yeah, because we realize if we want to make something a gas, we need to look at its boiling point. And 20 degrees Celsius, well, these guys, these, if you do the thermometer line, there it is. Where's 20 on this? 20 degrees is up here. It's in the gas stage. Gas, liquid, solid. Number line for this one. Right, so this is solid, liquid, gas. Where's 20? 20 is down here. It's in the solid mark. Next one, 800, 1400. Where's 20? 20 is down here. Solid. Yeah, solid, liquid, gas. I love the thermometer lines. Yeah, oh my goodness. You're never going to do that with diamond, are you? Anyway, so that one's going to be... Come on, little laptop. There we go. So it's going to be, which one's going to be a gas? And it's going to be A. Next, contains oppositely charged ions. So it's going to conduct when molten, but not when solid. There you go. C, we're done. It's knowing the properties of ionics there, guys. Some of the substances in the table are compounds. What is meant by the term compound? A substance that contains two or more different. Notice my capitalization. Yeah, 2 or more different types of atom chemically bonded together. Done. Next. The electronic configuration of sodium and chlorine are. Describe the changes in the electronic configuration when these atoms form sodium chloride. Right, guys, you can score every single mark on this question without even describing it. You can just draw the diagrams. So here's what we've got. We've got sodium. I love diagrams. Diagrams make me so happy. That wasn't too bad, that. Chlorine. Oh, no, I'm going to do them as dots. It's not bad. A bit wobbly, but not bad, considering I'm on a tablet. Oh, not bad. I'll take it. There we go. Product. So 281 and 287. It's now going to become this. It shrinks in size. It's lost its outer shell and now becomes +1 to a 1. And then the chloride, I'm doing it properly as well. Whew. Doing this really properly. I love it. Sorry about the quality of that bit. Gain sodium's electron. 1 minus 2,8,8 square brackets 1. And that gets you all of the marks. So just to explain that if you wanted to do it as a description, the marks are going to be coming from saying that sodium is going to lose 1 electron to the chlorine atom and the chlorine will gain it. Yeah, so the word version of this, the word version is going to be sodium loses 1 electron to the chlorine atom. Chlorine atom gains it. Chlorine atom gains 1 electron. 1 electron. Full outer energy level. Full outer energy levels achieved. Energy levels achieved. Is it I before E? Achieved 2,8 square brackets +1 for Na plus. You need to give this. They've given you the electronic configurations. There's going to be a mark for doing that, Cl minus. That's going to be the written version. I prefer the diagram. It's just preferred. It makes more sense to me that way. That's how I see this. Calculate the relative formula mass of sodium chloride. Nice and easy. Sodium is 11 and 23. Chlorine is 17 and 35.5. NaCl is just one of each of them. So 23 plus 35.5 gives me 58.5. Put it on the line. I'm done. Excellent. Next, number 6. Okay, titration curves. Ooh, hello, Mr. Titration curve. Okay, total volume of 50 centimeters cubed of acid is added gradually to 50 centimeters cubed of sodium hydroxide. Universal indicator done. What is the pH of the sodium hydroxide solution before any acid is added? 13. We're starting at the alkali in the beaker. Yeah, so the pH was 13. I like it. Next. What is the pH of the solution after 40 centimeters cubed is added? Ruler. That's a nice, easy graph, that one. It gives a really good, solid answer, doesn't it? So that's going to be, people are going to misread this now, aren't they? There's 1, 1.2, 1.4, pH 1.4. 1.4, making sense. It makes sense. It's gone very acidic. Yeah, because we're adding acid to the alkali. The alkali has been completely neutralized, so we're just ending up at an acidic pH. Yeah, 1.4 makes total sense to me. Next, what volume of acid is needed to completely neutralize the sodium hydroxide? So that's the vertical region. So when does neutralization actually happen? It's here. Yeah, we realize that this is a vertical region. So the answer was 25. Perfect neutralization is there at 7. Yeah, so we needed 25 centimeters cubed. Next, the table shows the color of universal indicator of different values. Complete the table to show the color of the solution when each of the volumes has been added. So the volume of hydrochloric acid added is 20 centimeters cubed. So at 20, we're here. Yeah. And then what was the next one? At 35. Okay. So first one is up here nearing 12. So where's 12? So we're going to be, is it actually above 12? It's actually a bit below. It's about 11. It's between 11 and 12. So that's going to be indigo. Weird. And then the next one at 40, 35, we're really quite low. We're at the 1.6. So it's going to be red. I like it. Seems reasonable. Write a chemical equation for the reaction between sodium hydroxide and hydrochloric acid. Sodium hydroxide plus HCl. State symbols. They are solutions. And we're going to form sodium chloride, solution, and water, liquid. Done. Nice and easy. How are we doing for time-wise? Doing okay. Question number 7. Okay, complete the table and give the identities of certain people. I love these ones. Right, so first stage, let's color code this. So magnesium and hydrochloric acid to make hydrogen. So F, it's going to be magnesium chloride, MgCl2. That'll be aqueous, by the way, in that reaction. The next one is they're going to burn this in air to form magnesium oxide. Gas G, of course, is going to be oxygen. Name oxygen formula O2, of course. Any element ending in gen or ene is in a pair. Don't forget. Next one. Ooh, there's a good one. Reaction with steam. Now, that's much more interesting, by the way. This reaction you also need to know. Magnesium plus steam. It does a very odd reaction. What we get is we actually get magnesium oxide and hydrogen. I know it's a funny reaction now. The demonstration is wicked, by the way. It's one of my favorite demos. But it is an odd reaction, and that one you've just got to know. That's a knowledge, that is. Just got to know that one with steam. Magnesium and steam. Again, edexcel really like it. Yeah, common. So magnesium oxide and hydrogen, they've actually asked us nothing about it. And the last one is we're forming magnesium sulfate. So sulfuric acid. Sulfuric acid. I like it. So identify the people. Solution F is, and it says, by the way, it's nice to say that they say the word identify, which is really nice because that means you can give either a name or the formula, either one. And of course, we all know that the formula is quicker. So if it said formula, you've got to give formula. If it says give the name, then you've got to give the name. It's a bit like that first question which Ben called for me because, he was like, you have to write down the letters. I totally would have dropped that, Ben. Absolutely. Was it Ben who caught that? Because that was super handy. You picked up my first mistake. Says to write letters. It was Ashley. Ashley caught it on the chat. Well done, Ashley. So solution, identify, solution F. Yeah, magnesium chloride, MgCl2. It's quicker. You can put the aqueous. The gas is oxygen. Yeah, we could have given the stuff it. Let's keep it easy for ourselves. O2 gas. And then the dilute, well, if you write O gas, you'll lose it. Dilute acid H is dilute sulfuric because it made a sulfate. Nice and easy. Excellent. Let's move on. Write a chemical equation between magnesium and steam. There you go. Mg solid. Now this one you have to have state symbols because they've given you a very specific type of H2O, which is H2O gas. Yet you now need state symbols. And you now form magnesium oxide as a solid and hydrogen gas. There we go. It all balances as well, which is super nice. Yeah, next. Moving on. Okay, draw a dot and cross diagram for the ions in lithium nitride. Oh, isn't that lovely? They've not even done it well either. Like that's stupid. Their picture's garbage. I don't like it with their little number 2 there. Don't like it. No. Okay, so and they want full as well because they've given you the examples. See, usually you can just ignore the inner shell of the metals. But in this case, they want us to do the lot. So what we're going to do is we're going to put the nitrogen in the middle. So how many shells does nitrogen have? Nitrogen has 2 shells. Nitrogen has 2 shells and 5 electrons in its outer. So 1, I'll do it as crosses. 2, 5 electrons in its outer, but it's now going to gain 1 electron from each lithium. And it's now going to become lithium 3 minus. Yeah, that makes sense. This is stupid, by the way. This is wrong. Yeah, they wouldn't do that. That is not okay. That is edexcel being really shoes. It's garbage. Yeah, the correct diagram for the oxide ion is just garbage. They're only showing the outer, by the way. The correct diagram for the oxide ion is this. Really winds me up. There you go. That's the correct one. Yeah, this is edexcel garbage. Hate it. So there's the nitride ion. And now what we're going to do is put lithium ions all around it. And we're going to do 3 of them. We need to do these as circles. So there's a lithium ion. And by the way, you can actually just do this. But I don't like it. It's not the way I would do it. I would do 3 of them. Because there are 3 of them. And each lithium has lost 1 electron from its outer shell to form this. Just to show you what the reaction looks like, here's what it looks like. Yeah, I'll even draw the inner shell, why not? So this is a nitrogen atom. Here's a nitrogen atom, missing 3 electrons. Here's a lithium atom, circle, circle, 1 electron in the outer. It'll give up its electron there. And we're just going to have another one going to do, well, okay, went a bit big there. Going to have another one do the same thing. Yeah. Another one doing the same thing, and then another one doing the same thing. That's what's happening. 3 lithium atoms are each giving it 1 electron. If they said ask for the reaction, that's what you draw. Yeah. And then the outcome is this one. So it then says write a chemical equation for the reaction between lithium and nitrogen. Okay. So Li solid. Reacting, you don't even need state symbols now, nitrogen gas, and it gave you the formula. The formula was up there. You should be able to build it anyway. Yeah, lithium nitride. If anybody's wondering how I build that formula, the reason being is lithium is going to become +1, nitrogen is going to become -1, crossing down. Yeah, I'm going to form Li3N, and then I can balance it. Messages coming through all over the place. Balance it. 3 lithiums, 3 lithiums, nitrogen's 1, I can do a half, and now double everybody. Double it, 1 and 6, and we're done. Right, guys, there's only 5 minutes left of our lesson, and I think that brings, oh no, I'm going to finish this question, then I'm going to mark it. So, state symbols. Yeah, state symbols. So we know that water is an L. Lithium hydroxide is going to be aqueous, of course it is. Yeah. All group 1 hydroxides are soluble. Ammonia is going to be a gas. Yeah, and it tells you in the question. There you go. And the word solution for the lithium hydroxide. So gas. Suggest a value for the pH of the solution formed. DMSing lithium hydroxide, pH 14 all day long. Reason. Lithium hydroxide contains OH minus ions, OH minus ions. These are alkali, strong alkali. These are alkali. And it's also a strong alkali, it's fully ionized in water. Yeah, I'm going to do that as well. LaOH is fully ionized in water. You don't need that. They're just going to say you want that, and that's saying that that's alkali. Yeah, that'll be the mark there. Solid lithium nitride conducts electricity and is used in batteries. Why would you expect solid lithium nitride not to conduct? Wow, that's weird, because it's ionic. Wow, that's super weird. Why would you expect solid not to conduct? Lithium nitride should be ionic, in nature, in structure, ionic in structure, and ionic compounds do not conduct when solid, since no since ions are unable to move. We're done. Right. Let's mark it, guys. Let's see how many of these I get right. I think it's very reasonable. We're probably about halfway through the paper now, I can imagine. Right, mark scheme. Oh, no, that's not going to be a good, I haven't even put it there anyway. So what I'm going to do is, if I go all the way to the top, come on, all the way to the top, I do have it on my desktop, and then I can split my screen up. Mark scheme. I always like marking these. Okay. Well, that kind of fits kind of well, to be fair. Right, question number 1. Let's see how quick I can do this. Switch my pen to red. Switch, no. There we go. And then check my size. Okay, right. Filter funnel, tick. Test tube or boiling tube, told you it'd be allowed both. Pipette, reject, teat pipette, dropping pipette. Isn't that interesting? But they just allow pipette. Graduated is absolutely fine because it's correct. And a beaker. And then E and A. Oh, in either way round, it doesn't matter. E and A. Well done. Thank you, Ashley, for catching it. I would have lost that. Next one is, of course, they contain hydrocarbons. Am I going to have got my subvert? Yeah, I like it. 2 marks there. First mark for S in box 1 and R in box 3. Second marks for box 4. Weird. Next. Right. Next one is 12. It is in group 2 electrons in the outer energy level. Thank you. And it's going to form X2 plus. Like it. 24. So there's the calculation at the top. Divide by 100. And the final answer being, it says, with no working scores 2, yada, yada, yada. It's the right answer. Yeah. Next. To increase the rate to provide activation energy is to provide. There you go. There we go. So it's in the except, but it says just to increase the rate or speed. Isn't that interesting? Yeah. But mine is accepted. I like it. It stops disappearing. There is black solid copper oxide. The mixture, it turns black. Any color other than black is rejected. Stops dissolving. There we go. Done. Remove the excess unreacted copper 2 oxide. I like it. Temperature decrease. Copper 2 sulfate are less soluble in cold water, or solubility decreases with temperature. There you go. Copper 2 is blue, and then it says, or filter paper, kitchen roll, tissue paper, or leave in warm place. Yeah, do not allow oven or hot oven or heat. Interesting. So they are actually just leave in a warm place. Yeah, but you don't want to say oven. If you say oven, they're going to take it from you. Paper towel. I'm taking it for paper towel. Do you know what, though? It's interesting, though. In this one, in 2014, they don't really want paper towel. Yeah, they want everything. Like, they give all these different examples. It's stupid. Filter paper. It's a good answer. I might stick with that next time. Okay, next one. B, D, A, and C. I like it. Next. Substance contain 2 or more elements chemically combined. I like it. Next. Na loses electron, Cl gains electron, Na becomes 2, chlorine becomes this. If correct number of electrons transferred, max 2, ignore reference to full shells, max 1 for mentioned correl, yeah, because that's completely garbage because it's ionic. All 3 marks can be scored from correct dot and cross diagrams show electron transfer. Ha! Loving it. Loving it. Next. 58.5, tick and tick, writing down the numbers, winner. Next one, 13, don't care about the 0, 1.4, 25, equation, indigo, red, equation, ignore state symbols, magnesium chloride, or name, arc oxygen, sulfuric acid, balanced equation, ignore state symbols. Doing well. There we go. They allow you to do the little 3 trick, but otherwise it's good. Do you notice, by the way, look, they haven't done the stupid pairy things in the mark scheme, have they? Bloody oxygen. I feel like that's a trap, that. Not really fair. 6, there you go. Multiples and fractions. They even allow the half. Ooh, I wouldn't recommend it. liquid aqueous gas, pH 8 to 14. I like it. Lithium hydroxide is an alkali. Hydroxide ions are present. Lithium nitride. Ionic ions cannot move. Since ions are unable to move, ionic compounds only conduct when molten or in solution. I like it. And that brings me to the end of my lesson today, guys. I hope you found it useful. Bring that back up to here. I have to say, I haven't found it particularly difficult up to now, but we are only halfway through. Be interesting to see what the second half. So far, the level has been relatively low. We've been running between, a level 3 up to about, I think the hardest one of the magnesium oxide reaction and a couple of chemical equations running up to about a level 6. There hasn't been any 7, 8s or 9s yet. The bonding one, maybe. There was a suggest why it doesn't conduct. That would probably be classed as a level 7. Actually, that was probably the hardest question on the paper, that last one so far. Anyway, guys, I will leave you be. Go and have a nice rest of your day, and I'll see you soon. The second part of this is coming up shortly. See you later, guys.